Today, we're diving deep into AWS VPC, Virtual Private Cloud, a core service that every cloud architect and developer needs to master. We'll be covering what a VPC is, its key components, security features, best practices, and a hands-on lab on AWS console. Let's jump right in. So, let's start with the basics. What exactly is an AWS VPC? According to AWS, a VPC is a virtual network dedicated to your AWS account, isolated from other virtual networks in the AWS cloud. This means you can define your IP address range, create subnets, and configure route tables and gateways, all within a secure, isolated environment. AWS VPC allows you to launch AWS resources in this logically isolated network. It gives you full control over your networking environment, including the ability to select your IP address range, create subnets, and configure route tables and network gateways. In essence, a VPC is your private section of the AWS cloud, where you can design and deploy your cloud infrastructure just as you would in a traditional on-premises network. The flexibility and control you get with VPCs make them the backbone of any robust AWS cloud architecture. Now that we've covered what a VPC is, let's delve into its key components. Each of these components plays a critical role in building and managing your network infrastructure. 1. Subnets. A subnet is a range of IP addresses within your VPC. You can divide your VPC into multiple subnets, each residing in a different availability zone, AZ. AWS recommends using subnets to group resources by common functionality or security requirements. For example, you might have public subnets for web servers and private subnets for databases. 2. Route tables. Route tables are essential for directing network traffic within your VPC. Each subnet in your VPC must be associated with a route table, which determines the next hop for each packet based on its destination IP address. The default route table provided by AWS routes traffic within your VPC, but you can add custom routes to direct traffic outside your VPC. 3. Internet Gateway, IGW. An Internet Gateway is a VPC component that allows communication between instances in your VPC and the Internet. It scales horizontally and is highly available, enabling instances in public subnets to connect to the Internet. 4. NAT Gateway. A network address translation. NAT Gateway allows instances in a private subnet to connect to the Internet or other AWS services, while preventing the Internet from initiating a connection with those instances. AWS recommends using NAT gateways over NAT instances due to their managed, scalable nature. 5. Security groups. Security groups act as stateful firewalls at the instance level. According to AWS documentation, they control inbound and outbound traffic based on rules you define. A key feature of security groups is that they allow you to permit or deny traffic to your instances, and the rules are automatically applied to any new instances that you associate with the group. 6. Network ACLs, access control lists. Network ACLs are an optional layer of security that acts as a stateless firewall at the subnet level. Unlike security groups, which are stateful, network ACLs apply rules to all inbound and outbound traffic at the subnet level, making them an additional layer of security within your VPC. Now, let's explore how you can connect your VPC to other VPCs or networks. AWS offers several options here, with VPC peering and transit gateway being the most prominent. 1. VPC peering. VPC peering allows you to connect two VPCs privately using AWS's global infrastructure, enabling them to communicate as if they were in the same network. Importantly, VPC peering is not transitive, meaning if VPC A is peered with VPC B and VPC B is peered with VPC C, VPC A cannot communicate with VPC C through VPC B. 2. Transit gateway. A transit gateway simplifies network architecture by acting as a central hub that connects multiple VPCs and on-premises networks. Unlike VPC peering, Transit Gateway supports transitive routing, allowing you to easily manage large-scale network topologies. AWS recommends using Transit Gateway for complex environments where multiple VPCs and networks need to interconnect efficiently. Security is a critical aspect of any VPC setup. AWS VPC offers several layers of security to protect your cloud infrastructure. 1. Security groups. As we mentioned earlier, security groups are stateful firewalls that control inbound and outbound traffic to your instances. AWS recommends using them as your first line of defense, allowing you to define granular access control for each instance in your VPC. 2. Network ACLs. Network ACLs offer an additional layer of security at the subnet level. Since they are stateless, you need to define both inbound and outbound rules for any traffic to flow. AWS suggests using network ACLs for fine-grained control over the traffic entering and leaving your subnets. 3. VPC flow logs. VPC flow logs are an essential tool for monitoring and auditing network traffic within your VPC. They capture detailed information about the IP traffic going to and from network interfaces, which is invaluable for troubleshooting and security analysis. AWS provides detailed guidelines on configuring VPC flow logs to meet your monitoring and compliance needs. To get the most out of your AWS VPC, it's crucial to follow best practices that ensure security, scalability, and efficiency. Based on AWS recommendations, here are some key tips. 1. Plan your IP addressing. Choose your IP address range carefully to avoid overlap, especially if you plan on connecting multiple VPCs or extending your network with on-premises environments. AWS suggests using a large enough CADR block to accommodate future growth while avoiding common IP address ranges that might conflict with other networks. 2. Segment your network. Using subnets. AWS advises using subnets to isolate different tiers of your application, such as front-end, back-end, and database layers. This not only improves security, but also enhances the manageability and scalability of your architecture. 3. Implement security in layers. Combining security groups, network ACLs, and flow logs ensures a robust security posture. AWS emphasizes the importance of implementing defense in depth, where multiple security controls are layered to protect your resources from different types of threats. 4. Use multi-AZ deployments. Distribute your resources across multiple availability zones, AZs, for high availability and fault tolerance. AWS strongly recommends multi-AZ deployments for critical applications to ensure continuity in case of an AZ failure. 5. Regularly review and optimize. AWS documentation highlights the importance of regularly reviewing and optimizing your VPC configuration. This includes checking for unused resources, optimizing routing and security rules, and staying up to date with the latest AWS features and best practices.
Welcome to today's podcast. We are going to focus on IPAM, or an AWS features that is very important when you want to delve into VPC war. In a few minutes, we are going to go step by step. How are we going to define our AWS IPAM? What are the different steps? And what do we expect once we have an IPAM deployed? Without further ado, what is an AWS IPAM? AWS IPAM is a service that provides centralized management for IP addresses across your AWS environment. It's designed to help organizations manage IP addresses efficiently by giving them a single unify view of all IP switches. Whether you are dealing with VPCs in multiple regions or handling IPv6 allocations, AWS IPAM simplifies these stacks, reducing the risk of conflicts and IP excision. How does AWS IPAM work? You might ask, to use AWS IPAM, you need to select a specific region where your IPAM manager will be deployed. What you do, IPAM automatically creates two default scopes, one for private IP spaces and another for public IP spaces. These scopes are critical as they represent the highest level containers. Reading IPAM, the private scope manages private addresses, while the public scope is designed for public addresses. Within these scopes, you create IPAM pools, which is a collection of contiguous IP ranges of CIDRs. These pools helps you organize IP addresses based on your security, routing, and application needs. For instance, you can create separate pools for development and production environments, allowing for better isolation and management. What are the key benefits of AWS IPAM? It might be a question that you have in your mind. There are 4 key benefits. For AWS IPAM, the number 1 is centralized IP management. AWS IPAM's biggest advantage is centralized management. You can manage IP addresses from a single point, eliminating the need to configure IPs separately for each VPC or region. This prevents IP conflicts and ensures everything is organized and efficient. As number 2, automated IP allocation. IPAM can automatically allocate IP addresses using a predefined pools. It follows your organization CIDR policies, ensuring consistent IP allocation across all VPCs and accounts. This reduces manual errors and simplifies network management. As number 3, we have the real-time monitoring and visibility. IPAM provides real-time visibility into your IP usage. You can track available IP addresses, monitor usage pattern, and receive alerts to prevent IP exhaustion. This ensures that you always have the IP resources needed to scale your infrastructure. As number 4, the last one, enhance compliance and security. IPAM supports compliance by enforcing your organization IP allocation policies. You can set rules for how IPs are allocated, ensuring that your network configuration meets security and compliance standards. In the next few minutes, we are going to delve into the lab. So please stay focused and let's have some fun. Thank you and bye for now. In the previous video, we saw what is IPAM Manager. We were better to go through the different definition, and we saw that we need to select a specific region or when we want to create an IPAM Manager. So what we are going to do is to select a region where our IPAM Manager will reside. Let's repeat the first step. So we have this one, we are going to select, for my specific case, US East 1. Okay, perfect. In the AWS console, I'm going to type IPAM. Then, click on Amazon VPC Address Manager. Then, create IPAM. You need to pay attention here. You need to check this box so that you will be able to create your IPAM Manager. As you can see, without that, everything's grayed out. So, let's check the box. Perfect. We are going to work on free chairs. Okay, awaiting the free chairs, there are only few options that you can perform. It is IPWS IPAM. But that's enough to understand how it works. Well, let's add a name. Let's type test. Description. A to select which region you want to discover. So there are a lot of things that you're going to be able to do. So, but what we have to do right now is to select the region that you want to focus on. So, I will select AUS 1 for Ireland. I will select as well AWS 3 for Paris. Another thing that I can select and that you need to see. You see our US East 1, North Virginia, is already selected. So the next one that's available is US East 2. That's the one that I would like as well to monitor. But you have the ability to monitor all of them. So by clicking Add All Region. But that's not our focus now. We only want to focus on 4 region, as you can see. 1, 2, 3, and 4. Then you can add some tag. That can be very useful in case you're using a for trust code. It's always good practice to have some tag. So you create your IPAM. Perfect. By clicking on Create IPAM. So your IPAM is well provisioned, as you can see our create completed. Okay? But there is something that you need as well to remember. Remember, during our presentation, we said that whenever we create an IPAM, there will be 2 scopes that will be created by default. You have the public scope, which is here. You have the private scope as well, with the read love scope, but by default, those 2 will be created. As you can see here. Origin region are AWS region where the IPAM is allowed to manage IP address CIDR. So the IPAM only discover and monitors resources in AWS region you selected as separation region. Remember, so those will be the operation region, and you'll be only able to monitor those region. Okay? The unassociated resource discovery is a resource discovery that has been associated with an IPAM. So when you create an IPAM, a default resource discovery is created for your IPAM and is associated with your IPAM automatically. So when you associate a resource discovery created by another IPAM, be sure IPAM, you can manage and monitor the IP addresses of accounts outside your AWS organization. It's very important. Okay? And you can see that is a default association. His click is written here is yes. Association state is completed perfect. Resource discovery are active. So whatever will be deployed in the previous region that we said will be able to be seen in this discovery. So we have there, they bring your own automation number. We won't focus on it. We have the tags as well. The next things that we have to do is to check. You see we have those 2. Scopes I will mention earlier. When you scroll to the right, you can see the state, you can see the type of scope. You can see that we have a private and public scopes. And how many ports do we have in each? 0 for now. Now the next things that you have to do is to create the ports. So what I'm going to do is to create ports. So by selecting in which scope I want to create ports, I will choose the private one, because in it public, here is seen. Whenever we choose public, we won't be able to provision public IP address because it will require a lot of things that we are not able to have within the features. But let's go with private scope. Okay? So this is the private scope. Perfect. Then we will put in IPAM private. IPAM private scope porter. Okay? The port hierarchy. Very important. So whenever you create a porter, you can have some hierarchy. And hierarchies has been shown in a previous video where we describe how the hierarchy works. In the sense that you have some port that will be arrayed up, and it can have sub-port that we use the CIDR that was previously defined. I mean by that, if you have, for instance, the 10.0.0/16, okay, you can have other ports that will take values from that range of addresses. So you have some sub-port that will be, for instance, 10.0.0/18. You see, it's reading this previous port. So that's why we have some hierarchy. So I will select the IPAM. Yeah, if it was not the free chairs, I could have selected as well this part. But This one is grayed out, okay? The only option that we have here in features is use IPv6. Also, there is also plan IP space within the scope, you see? This one is only available, okay? So the local, very important as well, so the local can be where our port we reside. Resources can only get IP address, a location from the port we needed pools local. So that's why we need to select a specific region, you see, we use this one. Then we have the CIDR to provision. So choose the CIDRs you want to provision for this port. If you do not provision CIDRs for the port, when you create the port, you can add them later by modifying the pools setting. And EULA nest mask. Okay? So I have /48 here. It's quite a lot of addresses. So when you go here, let's go to /48. Again, /48. As you can see, we have 10 to the power 24 IP addresses. That's quite a lot. So that will be enough for our specific case. Okay, you have now to specify the different values. So I will create the port by creating the port. CIDR with nextmax, perfect. We are here. So the port that we created is well provisioned and is written here, ID or the port. You can also find it here. Okay, let's come back to the polytails. Have the scope type here is private. And what type of address do you want to manage is IPv6 address. Then, automatically in power discover resources is no. We remember it was not possible to put yes within the features. So we have the IP space visual as well, that's not yet available. The CIDRs are here. Okay, allocation, compliance. I will put in the master network, the minimum and maximum that was shown in the previous section. We have the resource sharing, which are the elements that have been shared to our account. Okay, so as we might be in some organization, so abbreviate OU, we might have some resources that have been shared in such a way that our account will be able to see that our other accounts as well. So if you have some resources that have been shared through the service known as RAM, if you remember, you will be able to see it here. So resource share RN, okay, every tax, the poor RN. Okay, let's go back to the IPAM. So we have it here. Perfect. It's written there. So what we are going to do now, as we already have the IPAM, we are going to test, are we able to create a VPC that will take advantage of the IPAM? That's the question. So to do that, we are going to click here on VPC. Okay? Let's click on VPC, so there is no VPC already created. Nothing. So what we are going to do is click on Create VPC, the console, VPC only. Let's type test. IPAM allocated IPv4 CIDR block. Perfect. But do you remember, it was not available in your features, so we cannot choose this option. So what we are going to do for now is manually enter the CIDR block. So I'm going to say 10.0.0.0/16. What was available between the features is to deal with the IPv6. So what we are going to do is you click here on IPAM allocated IPv6 CIDR block. Then what we are going to do is to select the port. Affect the seed private port. And do remember, we choose the /48. It's .NET Maxland. What we are going to do now is we select 52 Tabagulia by selecting 52. Is to see how much percentage has been used already in the IPAM Manager console. So the tendency will remain default. And we click on Print VPC. This is successful. You see here we had IPv4 CIDR that we manually enter. And we have here IPv6 port that comes from IPAM Manager. Okay, next, let's check the CIDRs. By afraid you see, here IPv6 CIDRs. Here we go. We select /52. We select this /52. We are going to go back to IPAM Manager, okay? IPAM Manager. Perfect. What we are going to do next is to go to IPAMs. Okay, select the IPAM that we have. This one. Let's go to association. Is there. Okay. Discovery, we have this one. You see, we have IP allocated. We can see how many IPs has been already allocated. Monitor the VPCs that has been already deployed. So within a different region, the AOS one, we have some VPC there. Okay, perfect. He's able to discover what are the VPC that has been created in our English region that we previously selected. To remember, so this be able to really to monitor and to know how much pound IPs are still available. This is the account number and those are the region that we mentioned earlier. Okay, the operating region, those are this one, the resource sharing, we have nothing. How much IPs has been used by via our VPC. So when we go to the port, we select the port, reflect here, IPAM, perfect. We can see that there is some percentage, okay? Remember, /48 was EC2, that we select that, and we can see the amount of IP address that has been used. As you can see here, you have how much left? Available of 94, so we use 6% by creating our VPC. Okay? So the more we create VPC, the more the value we will choose. You can also take advantage of CloudWatch in such a way that by the power of the event-driven, if the pores are already full at some percentage. Okay, so let's see percentage of which is addition. Bridge 60%. So if let here is 6% right, assignment. But if it's already 60%, please provision a new pore. If you're interested in how to perform this action, please write down only the command. You can answer as well to other questions so that we can see some dynamic. Don't forget to like, subscribe, and share. Thank you, and bye for now. Today, we draw a simple cloud architecture using Draw.io. First, search for Draw.io on Google and open Draw.io page. Select more shapes and choose the AWS 24 bundle. In AWS, a key component is Amazon VPC, your private section of the cloud, where you can design and deploy infrastructure like in traditional network. Within a VPC, you can create private and public subnet, each in a different availability zone. Route tables, direct network traffic within your VPCs, with each subnet needing a route table. We'll place EC2 in a private subnet and EC2 in a public subnet. To give EC2 internet access, add a NAT gateway in a public subnet. Specify a route in a route table and allow an ingress rule in the security group. Don't forget the IGW, enabling internet communication for VPC instances. Tell me the command which to you use and find the hidden error in the schema. Hello everyone. In a previous video, we saw how to design a VPC. As an architect, we use Draw.io, which can be one of the tools that you will use in your specific job. But what we are going to do in this lab is to go step by step on how to provision an EC2 instance. In the subnet, it can be an EC2 instance, it can be database. The choice of EC2 instance, it make it simple so that a lot of people can understand it. The EC2 instance will be within this the private subnet. We will subdivide, we have two subnet, private and public subnet. So what we are going to do is to put a NAT gateway in the public subnet so that you can have access to your EC2 instance in a secure way. So what you're going to do is to have a NAT gateway. We have an internet gateway attached to our VPC. We take in consideration all these subdivision. So let's focus on these and please stay tuned till the end and let's have some fun. If you haven't subscribed yet, please hit the like button, subscribe, write some comment to support this channel and don't forget to share it. Thank you, and let's have some fun. Hello guys, so by clicking on create here, we are going to type the name. Let's type tech ref number, okay, VPC. Then you have the choice, either to put your IPv4 CIDR manually, or use the power of IPAM. This is very interesting because you will be able to avoid overlapping CIDRs. People already provide a video that explains what is IPAM and how to use IPAM. So if you haven't watched that, please have a look at the link in the description. Now we have the IPv4 CIDR, and we are going to type 10.0.0.0/16. You can also use the IPv6, but for this specific lab, there's no need. So we have no IPv6 CIDR block. You can choose default or dedicated. When you want that, if you choose dedicated, all the instances that you are going to provide will be on dedicated hardware, and that will be quite costly. For this specific lab, let's stay on default. You can choose some tags. That's a good practice. Let's click on Create VPC. Later on, you have your VPC. Now our VPC is available. You see the state available. So everything is created. But what do we have in the VPC? Almost nothing, right? And right now I'm showing something very interesting, which is the resource map. It's a new feature that was introduced by AWS and present in a recent event. So we have the VPC here. You have the subnet that are within VPC via your route table, and you have audio connection, network connection, then the NAT Gateway. It can be as well the IGW, the Internet Gateway, right? You have the knackers here, okay? So the knacker will be let's say your security rules that you are going to put on the subnet, okay? But now let's go step by step. What you're going to do next, you have your CIDR this here, you have your VPC flow logs. We won't create it for now, but we are going to focus on it later on. So you have your tags, you have your entity integration to the CloudWatch. Interesting. So keep in mind that those features exist, but for the simplicity to focus on how to provision this different subnet, we have to do what? We have to create this subnet. So by clicking here on the left, I will go to subnet, okay? On subnet, I will create two subnet. Of course, I will attach the subnet to my VPC, okay? So this is a CIDR block. So the VPC, we have a private here. So private subnet, okay? Reference is what I'm going to choose, a CUS is 1A. And now I'm going to choose the CIDR block. Remember, we have like 16. In fact, that's the CIDR block for the VPC is like 16. But I need to choose something else already in my subnet, depending on how many machine do I plan to have. Okay, so what I have is I will put it 10.10 and then .0.0/18. Perfect. That will give me 16,384 IPs. In another wall, potentially I can have 16,000 devices connected. But that's quite a lot, right? Let's decrease it to /20, so 4,000. Perfect. What else? I will create the subnet. Now let's create a public subnet. I will read the same thing. So I will put public here, public subnet. The availability zone previously was US is 1. Now it will be this one. That's the same. So what I'm going to do is choose 10.0.0/20 previously. But one thing interesting is that if we cannot have subnet that overlap, okay? So what we are going to do is to use this feature. Just check. Perfect, you see? By clicking here, I can see the next available CIDRs. And one thing interesting as well is that I can quit all my subnet at once. So I can click add subnet 2 and so on. So I will remove that because I already created the private. So this is the public app that I'm creating right now. So I will click on create subnet. Perfect. I will as well click here to clear feature filters. Yes. So I have two subnet, public and private. It's interesting to see where we are. So by going back to VPC, by clicking here, okay, I will be able to have a map, you see, resource map. This, in the previous section, it was not available. So we couldn't see the subnet a subnet was not yet created. So now we have those two subnet, and really they are linked to a route. Okay, our table. So what we are going to do next is to see how, to remember our goal, is to have an EC2 instance in the private subnet and to be able to communicate. So we can do in two ways. Either we create an EC2 right now, or let's finish to build him up, and then we are created where we will create the EC2. So this is what I'm going to do. So let's focus on the second option. Let's build him up. So what we are going to do now is to go for the Internet Gateway. Okay, you have the Internet Gateway where it is. So we scroll down, you look for Internet Gateway. So here we go, we have an Internet Gateway. I click here, I will create an Internet Gateway. I type EC2, ITW, perfect. Create an Internet Gateway. Do you see what is written here? The Internet Gateway is detached. So what we have to do now is to attach it to your VPC. Okay, either by clicking here or by going to this action, I'm clicking attach VPC. So I'm going to select the VPC. It's take with my VPC. I will attach the VPC. Perfect. Here we go. Then what you need to create now is the NAT Gateway. Okay, here we go. NAT Gateway. Perfect. Is what you need to create. So by clicking on create NAT Gateway, you will be able to have this interface and we type the name NAT Gateway. Okay, NAT Gateway. I will need to select the subnet where we reside. So for me, it will be on public subnet, and that's the good way to go. So connectivity type, select a connectivity type from that gateway is will be public. Okay, with elastic IP address, so how it can be rich. So need to choose the NIC IP address, please. Okay, the private IP address is optional, no need. For this specific example, there's no need to go into these details setting. So I will click on create NAT Gateway. So let's go back and see what do I have in the resource. So when I go back to the VPC, perfect. What do I have? I have two subnets. I have route table and I have Internet Gateway. But there's something strange, don't you see? There is no connection between a route table and Internet Gateway. But that raises a concern, how these things we communicate. So what we have to do now is to go to the route table. So what we are going to do at this level, we need to have some concern. The question that we are going to have whenever we click on route table, you can see that there is already one route table. Okay. But that raises a concern. Do we really need one route table or not? So what is the association within the route table? So by clicking on subnet association, you see that there is no association for now. Explicit subnet association, but there is a next subnet without explicit association, but you can see that there are subnet. So the route table is not yet linked to a subnet. You can see, because there is no explicit subnet association. But what can be linked? Those are the subnet. So what we are going to do is to use the route table that we already have and assign it to a specific subnet. Okay? So what we are going to do for now is to say edit. So for the public subnet, we are going to use this route table. Public subnet. Okay. So I will write here public router, so that I will remember what it's about. Then I will create a new route table. Route table, I will say private router. Always select the VPC, then click on create. So now, what do I have? If I go back to route table, I will have two route table, with a public one and private one. But there is something else that we need to do, is to be able to associate the subnet to my route table, to my router, right? So let's see to the route table. So we click here, private subnet. Perfect. Later on, what I'm going to do. So we have now, before going further, we have to pay attention that we have already two subnets associated. So what is the next step? is to go to the public route table. Now make a connection. I will say, so in a public subnet, whenever we want to talk to internet, we need to do some specific action. Which action, you may ask? So I need to go to the route table, you see. Whenever we talk 2/16, whatever, information we do, we will route locally. But what we want to say is that if I want to go to the internet, what will be the next step? I will click here on .0, then select the Internet Gateway. Why? Because I'm inside the public subnet. Okay, so we click on Save. What will be the next action? Is to go to the private, right? Private router. Click on the route table. There's no other rules. So what I'm going to do is I will click here and say, if I want to go to the internet, the only way is to go through the NAT Gateway. And I need to select the specific NAT Gateway. Click on Save. Okay. After I did that, there's one interrogation that I might have. How is the state of the resource map? So if I go to my VPC, I click on the VPC, I go to the resource map, what do I have now? I have a subnet, two subnet, I have two route table, public and private, and I have the connection, you see? So the public will go to EC2, the NAT will go here. Perfect. We are going to do something else that is very interesting. We are going to select the subnet. So what I'm going to do in the private subnet, I will go to the network access control list. There is something interesting here, which is written, allow. Remember this part. Let's focus now on. Remember this part. Let it as it is. Now, I remember as well the resource map. Is the resource map. Those are the connection. Our next step is to create an EC2 instance in the private subnet and to check if we have access to internet. So let's go to the EC2 instance, click on EC2, open in another window. I will do that, launch an EC2 instance, perfect. I will select Amazon Linux, the default shares, let's say in T2 Micro, no need to have something heavy. I'm going to create a KeyPAM so that I show you all the steps. So what will be, it will be like test, or it is this test lab. Yes, okay, create the KeyPAM. As you can see, I need to download the KeyPAM. Good to roll. Save. Tell the KeyPAM. Perfect. What next? Do you want a NIP IP and the setting? Very important. Don't forget, you need as well to set the rest to your network. Okay. So where do you want your EC2 instance to reside? I want it to be in the private subnet. It might be the case as well of a database that you want to isolate. That's why I'm putting now the EC2 instance in the private subnet to reflect how it will be in production. Okay? In case of database, in case of some valuable resources. So do you want an IP address? In fact, you can say yes, but there's no point, right, to have a public IP address for now, for this case. So this create a subnet, I will say, secure my resources. Perfect. Create a subnet, secure my resource. Then the description of the inbound rules. Perfect. Later on I can edit it, okay? So there is no point for now to worry about that. So this is okay, a DG here abide. Perfect, everything is done. Let's look at the button where to click. So now we click on launch instance. Good, we have it. Perfect. Let's go to our instance. It's up and running, okay? So what do we have? We have a private IP address. Reading our scope, so 10.0.12.16, perfect. No elastic IP, so no public IP. Okay, we have the status. Is the monitor or not? Issue code add, there's no alarm, of course, because there's no metric. Chatbot monitor is possible. We have security that has some security, but that's not the point for now. We have a specific lecture for that. So, to make it simple, remember, you have the EC2 instance, and when you click on EC2 instance, you have no public IP address. And that makes sense because it's a private resource. So, it means that you won't be able to access from your local network to that instance because it's not publicly available. To visualize how it can be done in production, you need to have another EC2 instance that will be in the public subnet, and I will check if the EC2 instance that is in public can be able to access to that, to jump to the EC2 instance, and from the EC2 instance via the ECC connection to connect now to the internet. I will go to instance. I will launch another instance. Let's say public EC2. Public EC2. This is how I will name it. Then what I'm going to do, select the key pair that I just created. Edit, the network. Select it with subnet, perfect. Allocation, I will enable you to assign public IP because I want a public IP address. Decrease the sub-security group. I will say public, publicly available. This SSH, perfect. Launch these two instances. Okay, here we go. We have the second EC2 instance that reside in the public subnet. Okay, so what you are going to do next, let's name it private so that we not forget. What we're going to do is to go to the public subnet. Let's look at, by clicking here, look at the configuration. So we have it here, okay. So it's publicly available. Is this one, the IP address. So it's okay. We have the public IP address. If you go to the instance, you're trying to connect. Each connection is opened all IP addresses. IPv4 address is perfect. You have the bottom, the connect button. Okay, so by clicking here, another window will open. You'll be able to enter in the pop EC2 instance. Okay, perfect. So you are in the EC2 instance. Then we clear everything. I do these. Perfect. It's good. We have the EC2 instance, right, in the public subnet. So how I'm going to access the private instance? That's the question, right? Okay. Remember, we had our EC2 instance. We have the public and the private one. Our goal is to be able to connect our EC2 instance. So from the public to the private, I mean to say, as our private EC2 instance is already is isolated in this private subnet, we need to find a way to connect to that EC2 instance via an SSH tunnel. One of the requirements is to make sure that in the security we have, please pay attention here on this table, we have what we call a security group. What you need to do is to make sure that this security group that you will put here, ISMP, Holy Connection SMP, will be the security group of the public EC2 instance. That's the first thing. In case you want to check the ping connection. And I repeat the first step. You need to make sure that whenever you do a ping connection to the EC2 instance, it works. Okay? To make it simple, if you go there on security, you will have this as public as here ID. So the security group ID. If you go back to the instances, to this list, you select the private instance, you go to secure. You do control. So you're trying to do control F. You will see that is the same. Okay? So what I will do now is to go to instances to try to connect from the public instance. So this one, via this option is to instance connect. You can open in your terminal a connection. So you will have a terminal, you will have your terminal. So this is this terminal, it's your terminal. It's like this one, where you'll be able to run your command. But that's not what I want. So what I want is to be able, let me close these, so that I will not have a lot of windows. I will not get confused. So let me refresh, remove the filter. So just focus on the running one. state running state. Instance state. Instance state. I put running equal to running. Perfect. So we have these instances. What do we do just after that? What we do right now is to go to connect. Select SSH connection. Choose this option. Now open my terminal. This one. Okay. LS. Okay. Perfect. Clear. What I will do SSH. I can just copy and paste this command. Okay. Ladies. Let's try. It works. Yes. Here we go. Back permission. Test lab are to open. Yes, it's normal because we didn't follow the right way. So we need to code this command chmod 400 so they will not be too permissive. So we have this one. If we do this, perfect. Let's clean it. And let's run the command again. Perfect. It works. So from now on, what we are trying to do is to be able to connect. In fact, to ping the private instance. And for that, I will take this IP, this private IP. So I will do ping like this, and it works. Okay? That means what? That from the EC2 instance, the public EC2 instance, I'm able to see the private EC2 instance. So I will clear that. Control C. Perfect. Am I able to do the SSH connection? That's the good question. For that, I will need something, right? If I go to EC2 instance, just see, private, I click on connection, there is a similar command, okay? But there is one issue. Guess what? Tell me. Yeah, you found it well. There is no file, the test-lab. So if I do that, I do yes. The test-lab is not available. Okay? This file is not available. Why? Because for the ls, there is nothing, right? So the first thing to do is to push my file. So this keeper to send it to EC2 instance, to the public EC2 instance. And for that, I will use some command scp-i. Let's make it simple. Okay. And we do this. Then we do that. A scp. Okay. Does it make sense? No, it won't make sense. Why? Because I'm already inside the EC2, the public EC2 instance. So what I need to do is to exit. Okay, let me close the connection. Let me clear it. Let's go back to the previous command that I use. Okay. So what I will do is scp. Okay. So I have these. What I want to do is to send this file. Perfect. If I can do that, and do these directly. Let me clear these. Yep. But to the end, and what I will do, I will say I want something like that. In the repository, by default. So, we hit walk. Let's check. Perfect. It's successful. So you went. Let me try to connect. SSH. Then I will put these. I will clear. The string into ls is there. You see it? Perfect. So now, what about ls-l? Okay. Can see something interesting. Okay, let me clear it. let's follow the correct way. So I will do it again because let me do it again. So I have this one. Fish mode P2C new file inside the EC2 instance. So I need to execute this command. Perfect. Now, the private, to access to the private, I will execute this one, this command. Do you see it? Perfect. I will type there. It is. Here we go. What does it mean? We are already inside the private. Do you see that? Inside the private EC2. A private EC2 instance. So now the question is, do we have access to internet? If yes, that means whatever we did earlier works, because if we deploy a NAT gateway in the public subnet in the independent route table, we were able to make the connection from the private subnet. We have to go through the NAT gateway, and we define that within the route table. So let's check. Can we do ping to Google? Let's see. If it works, that means our design is correct. Yeah, here we go. It works. So, that means what? If you go back to the table, to the table, let's go back to VPC. So we did it well. In a route table, let's go. We have the private router, okay, so the route table. To remember, we say everything that we go to internet has to go through the NAT gateway. So it means that if we delete these, normally it shouldn't work. It should not work if we delete these. Okay. So let's try again. Proceed. Let's clear it. Let's try. You see, it doesn't work. So the solution for that is what we did earlier. Let's edit our router, our route table. You see, everything that we go to internet has to go through our NAT gateway. So we allow our EC2 instance to initiate the connection to internet. So it means that, you see, start working. It means that we securely design our VPC and only connection within that ensures a way that whenever we want from the private IP, private subnet, whatever is deployed in private subnet can initiate the connection to internet via the NAT gateway. But from the internet, you cannot initiate the connection because there is no route. Okay? So, that's the same. In the public subnet, you can do whatever, because whatever is there should be accessible to internet. This is what you will usually do in production. Of course, there are a lot of things that you can implement to make it more secure, but this stay over our idea, and we reach our goal. We are able to do that. As you can see, the design is correct, and we have our EC2 in the private. You see 10.0.12.14 CD IP address. So our private EC2 can initiate the connection to the internet. It was my pleasure. Please don't forget to subscribe, to like, to put some comment if you have any question, or also to share, to support this channel. Thank you, and bye for now.